All right, guys, it's on with our third video, a third method that you have to use if you'd like to solve systems of equations, and that's something called the elimination method. Now, elimination method, if you came up through the public schools and whatnot, is planned to really be taught to you your freshman year. So hopefully you learned this your freshman year, maybe towards the end of fall semester. If you're currently taking Algebra 1, it's probably you haven't learned the elimination method yet. I'm teaching it, for instance, my Algebra 1 students in about 2 weeks or so. But anyways, it's another good way to solve an equation. So the elimination method is where you use the addition property of equality to solve. So elimination method, if you've done it before, involves adding the equation to the other equation. That's it, adding one equation to the other equation. And if you've done this before and kind of remember it, the idea is you add the equations together and that eliminates one of the variables. Okay, so just a quick reminder in the problem, in case you're diving on here, we got to get JM the same length as LK, and we also got to get ML the same length as JK in order to make this pave the way for the quadrilateral to have to be a parallelogram here. Okay, so that's how we get these two equations. We got equation number 2 right here. Okay, or equation number 1 right here. 4x plus y has got to equal 42 in order for this for it to be possible to be a parallelogram. And then it's definitely a parallelogram if this is also true here, right? 3x minus 2y equals 26 here. So now we got to think, okay, we got to do this through elimination. So the elimination method is pretty much adding equations with one another, okay? So for instance, if I try to add that equation to this equation, does it eliminate a variable? And the answer is no for now, so I'm going to show you the way in a second. But just take a quick second, maybe this reminds you of what elimination is here, is that I can take this, right? I can take this here, and I can add this to the left side, right? I'm going to add this 4x plus y to the left side, and I'm going to take this 42 here, and I'm going to add the 42 to the right side. I am technically allowed to do this. I am allowed to do this. I'm allowed to manipulate equation 2 by adding 4x plus y to the left side and adding 42 to the right side. And that's going to result in a valid equation. It's going to result in a valid equation. Yes, it will, right? 26 plus 42 is 68. 3x plus 4x is 7x. Negative 2y plus y is negative y right here. Okay, so if I wanted to, I could do that. And that is one of the steps, but it's going to look like one of the steps once we get to elimination in a second. But I wanted to point that out to you that you're allowed to do that with equations. Why are you allowed to do that for those equations? Wait a second. Why was I allowed to add 4x plus y to the left side and 42 to the right side of equals? Why was I allowed to? Well, the addition property of equality, okay? So the way that's going to be important to understanding the elimination method and understanding why you can do this is to understand the addition property of equality. When you have two equal things, right, and check it out, 4x plus y is equal to, right, equal to 42. So I'm allowed to take this and add it to the left side of the equation. And I'm allowed to take this and add it to the right side of the equation. And if I'm adding one thing to one side of the equation and an equal value to the other side of the equation, my equation remains balanced. And that's the addition property of equality, right? We have if A equals B and C equals D, then A plus C equals B plus D because I added equal values to both sides here, okay? So this example that I just did right here isn't really the eliminating anything. Okay, eliminating things. So what we're going to do in a second is we're going to talk about how I could eliminate a variable. Because notice this here, I almost eliminated y, right? I had negative 2y in here. I added 1y, and then that left me with just negative y here. Question, right? For those, this might jog your memory a little bit if you're studying elimination, if you study elimination in Algebra 1. What's one thing I can do before I add the equations together so that I can eliminate a variable? Perhaps eliminating y. So let me clear this out. Because you might as well just see the whole example, because I would never have started it like that. I'm just showing you the idea of elimination, why it can be justified. So let's check it out here. What can I do? Well, if you thought a second ago, right, if I had this, right, plus y, and I added this plus y over here, that brought me to negative y. That's not great because y didn't get eliminated. But what if I had added 2y over here, right? What if this were 2y, okay? Then that would have eliminated the negative 2y. Right? If I added something that's the opposite of this, right? That's the inverse, the negative 2y and 2y are additive inverses, we'd end up with 0 as the amount of y's we have. So what you can do in this situation if you want to solve a system using elimination is if you can get opposite coefficients, right? Opposite coefficients in one equation as the other, then you can use elimination. So what you can actually do is this. Check it out. I'll go ahead and erase that for a second. I could actually, what if I actually use the multiplication property of equality? If I doubled this left side here and I doubled the right side here, that actually does put it in position to use elimination in a second. So let's check this out now. 2 times by 4x is 8x. 2 times y is 2y. And 2 times 42, well, that's just 84. Right? That's just 84. So, right, you might be totally lost, but like you'll see in a second. Hey, legally, I set up this equation, right? If I had to get 4x plus y equaling 42 in order for this to be a parallelogram, then, right, if that's a true statement in order for this to be a parallelogram, then if I double that statement, right, multiply 2 to the left side, 2 to the right side, that is still a true statement by the multiplication property of equality, okay? And that's important because check it out here is, okay, we're going to add to equation 2. Okay, so we sort of rewrote equation 1 in a way that we had this, it's really all about this here. The key thing was getting the plus 2y right here, because check it out, we're going to add it to the other equation now, and it's going to eliminate the amount of y's we have. We had negative 2y originally, we're adding 2 more y to it, that's going to bring it to 0. So check it out here. I got 8x plus 2y, and that equals 84. And now I can addition property of equality it. Look, I can add this to the left side of the equation up here and add this to the right side of the equation here. And what ends up getting eliminated, right? I got 3x plus 8x is 11x, but negative 2y plus 2y is 0y, or just 0, okay? And then that equals 110. So I end up with, let me just cross that out of the way, ends up with 11x equals 110. Did you see it? Did you see it? Did you see what happened? That was a big moment. Okay, so make sure you go back and check it out for a second. I added this rewritten equation here, added it to this one here, and it eliminated negative 2y plus 2y. Boom, we eliminated that variable. The 3x plus 8x is 11x. 26 plus 84, we know from the video number 2, that's 110. Divide both sides by 11, and we get x equaling 10. X equaling 10. And that's a start to solving this one. But remember, wait, we've seen x equals 10 in the last 2 videos. So regardless of method, you get the same answers. So what we got to do is, again, go back to equation number 1 and solve it here. And our equations haven't changed at the beginning. So we know that our answer is going to be 2 for y. And then we'll be good to go. 40 plus y equals 42. Minus 40 from both sides, y equals 2. And there we got our answer. X equals 10, and 10, and y equals 2 for this solution 1 here. Okay, so if you want to use the elimination method, by all means, you can do it. So what is elimination method? That's using the addition property of equality to add different equations to one another, right? Adding equal things to each side of the equal sign. So if you can get the opposite sign, right? So if I had 5x on one side and I can add a negative 5x on that same side using a different equation, then I might as well do that, and that eliminates x. I can solve for y, okay? So that's the idea of the elimination method here. Hopefully that method made sense. Maybe watch this video again if you want to use this one, but the big thing is here, when you get problems like these, you're going to have to pick one of these methods and figure out how to solve, okay? I'm going to include some Khan Academy practice if you want to practice some of these things. But again, this is an Algebra 1 topic, so I put this up here as sort of optional videos, optional practice. So you're sort of optional. Reach out to me if you need help, right? Try to figure out how to do this because we got lots of other stuff to learn this year. Not enough time to spend multiple days reviewing substitution video. Because again, that's Algebra 1. And you get it more in Algebra 2. They'll actually have some actual lessons for you in Algebra 2 about systems. Email me if you have any questions. Have a good rest of your weekends or a good day or whatever. And hit me up if you need anything. Bye.